Okay, so today we're going to continue on learning about logs, but first we're going to go back and take a look at some ACT. These were all ACT warm-ups, so give these a try. Okay, these are ACT. We're going to pick up where we left off with number 19. The first one's about scientific notation. The next one's about angles. The last one's seeing if you know what to do with percentages. So when you're ready to check these, press play. Okay, so let's take a look at these. When we add these two numbers, we get 1,370,000,000. And so in scientific notation, what we do is we would count the number up to that first digit. Your leading digit is a 1, so it's 1.37 times 10 to the 9th because we would have to move that decimal 9 places. Number 20, if these are parallel, then that makes these two angles here and here same side interior angles. And same side interior angles are supplementary. Supplementary means they add up to 180 degrees. So to find the measure of A, we just do 180 minus the x. Now this last problem. On the last one, we do 80% of 1,000 and 60% of that, or you could have just done 1,000 times 0.8 times 0.6 to get to the 480. All right. Today's lesson. Okay, so these are notes that you're going to take on notebook paper. All right, so go ahead and get out some notebook paper. And when you are ready, whoops, I went a little too far. When you're ready to start going over them, press play again. So you may want to go ahead and set this up and be ready to roll. So today we're going to look at solving logs and exponential equations. So mainly all of our equations are going to have logs. They're either going to have logs on one side of the equation like this one, or they may have logs on both sides of the equation. So the reason we did our properties first is because we have to use those. So here are our steps to solve these equations involving logs. If they just have a log on one side, we're going to condense those logs to a single log. Then we're going to switch forms. So we'll switch from log form to exponential form and solve. And you can always check your solution. All right, so let's take a look at this. Now this is addition. Let's remember, we can rewrite addition as multiplication. So this becomes log of 5x times 2 equals 2. Well, that's just log of 10x equals 2. Now, this is in log form. My understood base is base 10. So when I go to switch forms, it becomes 10 to the second equals 10x. Or 100 equals 10x. So x is 10. Okay, so if we plugged in 10, we'd get 50, and 50 times 2 is 100. And what power do we raise 10 to get 100? The second, so it checks. All right, now the other thing we want to do when we check our solution is make sure that we plug it in. We do not have a negative base. We do not have a negative answer, because if either of those two things happen, it's an extraneous solution like we talked about last week. All right, example 2, very similar. We have logs, this time base 6. They are added. So when we condense them, this addition switches to multiplication. And then we switch forms. So it becomes our base is 6, our exponent is 2, our answer is 2x. So we get 36 equals 2x. So 18 equals x. All right. And if we plugged in 18, it gives us a valid equation, and we're good to go. Okay, so we're checking to make sure when we plug it back in, we don't have a negative base, we don't have a negative answer part, because either of those would give us an extraneous solution. Okay, more examples. So if you want to write these down, then you can press play when you're ready to listen. Okay, this first one, we have logs on one side. We're going to condense. This subtraction gets rewritten as division. Now we have it written as a single log. Once we get it to a single log, we switch forms. 4 to the third equals x over 8. 4 to the third is 64. So to solve this one at this point, we would have to multiply both sides by 8. And 64 times 8 is 512. It's like 8 to the third. 512. So if we plug in 512, positive 5, we're good. We're good. So always check. All right, example 4. We have logs on one side. When we have logs on one side, we condense. So this subtraction becomes division. And then we switch forms. All right, don't let it trick you. It's an understood base 10. So it becomes 10 to the first power equals x squared minus 1 over 12. All right, well, 10 to the first power is just 10. So to solve this, I'm going to get that 12 out of the denominator quickly. And that gives me 120 equals, it cancels over here, x squared minus 1. We add 1, and we get 121 equals x squared. So if this were just an equation, remember we get plus or minus. Now, I said we can't have a negative, but let's see what happens to that x when we plug it in. The x gets squared. So whether I test a positive 11 or whether I test a negative 11, the first thing that happens is it's squared. And this becomes positive. So both of these are good, even though one of them's a negative. When I plug it in, it's not negative. It gets squared. So both of those work. Okay, example 5. Take a moment and write it down, and then when you're ready, press play. Okay, so the properties of this give us a little more work. So we've got this multiplication out in front that we need to rewrite as a power, and then it becomes multiplication. So really, this is log base 10 of 4x squared equals 2. All right, I have it as a single log. Once you have it as a single log, you switch forms. Once again, we have that understood base 10. So it becomes 10 squared equals 4x squared, which is 100 equals 4x squared. So we get 25 when we divide by 4. And this time when we take the square root, we get plus or minus 5 equals x. But look at this, guys. The way the original problem is written, the original problem before I did anything to it, if I plugged in a negative 5, I'm getting a negative answer part right here. And that doesn't work for this problem the way it is originally written. So this is my only answer, positive 5. So I want you to notice the difference. The way the original problem was written, this is not being squared. The way the original problem was written, this is being squared. So there's your difference. Okay, so case 2. What if we have logs on both sides? So you're going to need to stop the video again, take a minute, write down the notes, and when you're ready, press play. Okay, so this says, what do we do when we have logs on both sides? Step 1, if you have multiple logs on either of the sides, you need to condense those to a single log. Then, once you have logs with like bases on both sides, all you have to do is set the answer parts equal and solve. And then you check to make sure your answer is valid. So in this example 6, this one's pretty simple. There's nothing to do over here because it's a single log. There's nothing to do over here because it's a single log. Now, let's see if we can do this. Do our logs have the same base? Yes. So if they have the same base, the only way this can be an equal statement is if this answer part equals this answer part. That's the only way. So all we have to do is set 3x minus 4 equal to 2x plus 6. And then we solve. So we're going to subtract 2x. And we're going to add 4. And we get x equals 10. Now let's go check before we say that's an answer. If I plug in 10, I get out positive 26 over here and positive 26 over there. So yes, that one works. All right, so I called this one a U-try. I do want you to pause it, give it a try. It's not hard, but it is going to give you a quadratic. So remember what we talked about last week on how to solve a quadratic. Okay, so since you've given it a shot, because it is log base 10 and log base 10, understood, we can set these answer parts equal to each other and solve. X squared minus 9 equals 5x plus 5. I'm going to move everything over to one side. So this becomes a negative 5x, and when I subtract the 5 from both sides, that gives me minus 14. So this factors to x minus 7 and x plus 2. So possible solutions are positive 7 or negative 2. Now, 7, when I plug it in, I get 49 minus 9, and 35 plus 5, 7 works. Negative 2, when I plug it in, I get 4 minus 9, which is negative 5. I can stop there because my answer part can't be negative. I can verify it by plugging it in here. Here I get negative 10 plus 5 is negative 5. Can't do that one. That's an extraneous solution, guys. That negative 2 is a solution we found algebraically that is not a solution to our original problem. Okay, we have 2 more examples before you go ask for your homework. 8 and 9. So if you want to write those down, go ahead. And then press play. Okay, now we have logs on both sides of the equation. So we want to get it to where there's one log on one side and one log on the other side. Okay, that's our goal. Or we want to get it to where there's logs on one side and numbers on the other, which we can. So what we're going to do here is condense. Let's condense this side. So we're going to bring that 2 back. So we get log x squared divided by 3 equals log of 12. So now we have logs on both sides, same bases, so we can set the answer parts equal and solve. All right, to solve this one, we have to multiply by 3, and then we get 36, and then we take the square root, and we get plus or minus 6. But when we look back up, the negative 6 gives us a problem there. So our only solution is positive 6. Okay, I'm going to show you 2 ways you could work this problem. One, you could create a situation where we only have logs on one side. Or 2, we can look at it where there's logs on both sides. Okay, so the way we get just logs on one side is we take this guy and move him over here. So to move him over there, you would have to subtract. So we subtract this from both sides. And that's what it looks like. So now logs on one side, we condense. So this becomes 24. The minus becomes divide, 4x. So that simplifies to log base 3 of 6 over x. Now, our next rule was, once we get it down to one log on one side, we switch forms. So 3 to the first equals 6 over x, and we solve. So we're going to have to multiply by x to get it out of the bottom. So we have 3x equals 6, so x equals 2. And we check, 2 works. It's a good answer. Okay, so now how in the world can we do logs on both sides if we have this crazy number? Well, we could rewrite it as a log base 3. Okay, so if my answer is 1, 3 to the first is 3. So I'm rewriting 1 as log base 3 of 3. And you can do that anytime. If you have 1, you just look at your base, you put your base in your answer to match, then it's a 1. If it were a 2, we would have to have the 3 here and the 9 there. All right, So let's take a look at how this would progress. And if we get the same thing. Oh, I hope we do. All right, so this becomes multiplication, log base 3 of 12x when we combine these two. So now we have logs on both sides, so we set the answer parts equal, and we solve. We got the same thing, yay! All right, so you can pick your method. Which method do you like best? We actually could force all of them into something like this. If we wanted to move all our logs to one side and switch forms. I don't know that that's always the easiest way, but it can work. All right, so we're back to the first slide. So we're done for today. Take your completed notes and show Miss Willoughby, and you can pick up your homework.